Welcome to MyProjectBazaar.com. Now we discuss about the product for on-system on-chip testing using hybrid test vector compression. Next we see the abstract for the product. Advances in chip design and technology have allowed for the integration of large number of cores into the system on chip. However, the resulting system complexity makes it a major challenge to design and testing reliable system. Multi-core system designs exacerbate power concerns and add the test complexity, but also offer the exciting the design for test opportunities. Many difficulties of the test arises from the use of deeply embedded cores. For these designs, a test access mechanism is needed that allow the core to be efficiently accessed and tested. Using a general embedded core test methodology such as the IEEE 1500 cores can be wrapped to prevent interaction with outside data source and allowing the test for a single core to be generated and applied to each instantaneous of that course. IEEE 1500 provides an efficient solution for testing cores allowing the parallel testing access mechanism. The increased use the multi-core chip dimensions per core complexity and also demand the parallel design and test technologies. As an especially important evolution of the multi-core chip has been the use of multiple identical core, providing a homogeneous system with various merits. This paper introduced the novel text access mechanism for parallel testing multiple identical and faulty cores to derate the chip by executing it. Instead of the typical test response data from the cores, the test output data used in this paper are majority values. Thus, the typical test response from the cores on all the cores can thereby the tested parallel and test cores. In both test pens, proposed TAM can be implemented with on-chip comparator. Shows with the proposed TAM can test multi-core in this paper, shown in the proposed TAM architecture. The pipeline-based TAM allows for a great deal of flexibility in test applications, and the pipeline helps to improve the time and reduce the capture power requirement. A partition scheme to enable the broadcast TAM to achieve high diagnostic resolution. This scheme requires the addition of few extra chip output pins which allow the core level failure to be detected from chip level automation test equipment measurements. These the variable and valuable parallel TAM methodologies has been researched by the EDA vendors on a recent paper about the design and test for a multi-core system by a processor for IP vendor gives a good description of application of parallel test access mechanism. Next we go to the flow diagram for the process. These are the flow diagram for on-chip test vector compression. We implement the compression based work using the string conversion technique. This string conversion technique to split the overall test output data bits into MSB and LSB section and to reduce the compression test data bits. These are the overall flow diagram for the process. The test control function to be implement the clock and reset element and the test mode and normal mode architecture. This test mode and normal mode architecture to create the present and gold signature for overall architecture. Clock reset control element basically to function the automatic test pattern input generation out input data bits to passing these four core architectures. This core architecture one adder and comparator and subtractor and multiplier element. These four elements to important elements for every ALU architecture process. So we focus the arithmetical element for overall core processor, and we apply the input in different kind of input in the four architecture and to produce the four kind of test output data bits for our required testing process. This testing process to split every data bits into two sections. Each section to be consist of the 8-bit limitation. This 8-bit limitation to produce the string conversion technique. This output data 8-bit output to be converted into the any one of the string values and to create the present signature and to already save the normal mode to be stored in the output golden string conversions values. These two values to be compared with the output response comparator and to every time to check the present and golden signature for overall architecture process. Then to identify the fault detecting in core wise, separate core wise and overall core wise in fault status level and to produce the performance analysis for overall architecture process. These are the final flow for overall testing processing architecture. Finally, we see the output for the product. These are the final text access mechanism output for Xilinx IoC project file. Just double click and open the Xilinx software. Then we implement the VHDL code for overall testing oriented process for 4 core architecture. Then to select the simulation process, to select main file and to simulate the simulate behavior model. This behavior model to represents the every time we apply the clock input signal and to passing the data one by one and to produce the dist output data and to compress the output data into the string conversions and to compare with the present and the golden signature and to produce the output data bits. Then to apply the reset functions to be 1. Then to reduce the reset function to be 0. So every time we update the clocking functions for overall architecture process. These are the output variations for overall architecture and to reduce the if the node to be for all core architecture to running perform correctly. If the subtraction to be error, the subtraction output to be error for overall output data bits. Then to change the golden and present signature variations. These are the string conversion for overall architecture. Every time we update the 16-bit limitation and to convert the LSB and MSB section and to produce the string data bits for overall architecture. This string data bits to compared with when the output to be correct or fault output to be inserted in overall output data architecture. This architecture to identify the problem for separately. These are the final simulation diagram for our string conversion overall architecture process. Every 4-bit to produce the output data bits and to golden signature and present signature variations to create the output data bits equally. Then we go to the implementation work. Implementation work, we analyze the area and time complexity for overall architecture. We just open the RTL diagram and to view the logical diagram representation for overall architecture. These are the RTL diagram and logical diagrammatic representation. And we go to the technological diagrammatic representation for our required testing architecture process. Then we go to the synthesis report and synthesis report to analyze the device utilization summary for overall circuit complexity for in our testing architecture. Then we go to the timing summary for our test compression result. These are the timing report for minimum period and frequency level and the latency time for overall testing architecture with the 4 core testing process. These are the final output for overall string conversion based testing operations.